We were solving, we started O level physics 5054 variant 22 October November 2021. We were solving paper 2 theory questions and we solved first two questions. Today we are going to solve third question of that paper. Third question is about the refraction laws and the light, and we are going to figure 3.1. This figure shows light entering a transparent block. This is a transparent block and it entering from some other medium to this medium, so two different mediums. So when light enters from one medium to another medium, then the refracted ray changes its path and in the next medium and it bends away or towards the normal. This is the normal line, and here is the theta is the incident angle of the incident ray that makes with the normal to the surface, and this is the angle which is the it makes the refracted ray makes with the normal. We can show clearly that the refracted ray has been bent towards the normal. So when light enters from a lighter medium to denser medium, the rays of light bends towards the normal. So when it bends towards normal, it means then the medium is denser. So in denser medium, the light will travel slowly as compared to the lighter medium. So question is, the angle between ray in the block and the vertical side of the block is phi. This angle is phi. The light travels that phi. Question is, light travels more slowly in the block than in air. Explain figure 3 how figure 3.1 shows this. As I told you that as the incident angle is greater than the refracted the angle made by the refracted ray with the normal, it means the light has the refracted ray has bends towards the normal. It means that this medium is denser than the air, so in denser medium the light will travel slowly. So this is how this figure showing that the light travels more slowly in the block than in air. So we will write how, as shown by figure 3.1, that refracted ray has bent towards the normal, showing that incident angle is the angle made by the incident ray with the normal to the surface. Incident shown that the incident angle is greater than the the angle of refraction, not reflection, this is refraction, which shows that block is denser medium than air, which shows that light light travels more slowly in the block. So if you write this much, you will earn the full marks of that. Second is state what happens to the wavelength of the light and what happens to the frequency of the light. So we know that we have a formula as V is equal to F into wavelength. So F is the frequency. Since the frequency speed has decreased in the denser medium, so this means that wavelength also decreases. But frequency will remain the same. Frequency will remain the does not change. It remains because this decreases, so overall uh, this will be decreases, so we can say that wavelength decreases in the denser medium and the frequency does not change. The refractive index of the transparent medium is 1.6. Angle theta is 45 to determine angle phi. So for this we have Snell law is equal as n, the refractive index is equal to sine I divided by sine I divided by sine R is angle of refraction here. So according to given condition n is 1.6, 1.6 is equal to sine I is 45, sine 45 divided by we show that if we cross multiply we get sine R is equal to sine R is equal to sine 45 divided by 1.6. So if we solve it, sine 45 is 0.707. By using calculator we can to be 0.4419. We have to find R. So R is equal to inverse of this. We get sine inverse of this, and by using calculator sine inverse of this will give us to be 26.22 degrees, which is can be rounded off to 26 degrees. Okay, we have to find phi. What is phi? Look here, we have calculated this angle. If I can draw it for you, this angle is R. This angle here phi is R plus phi plus R is equal to 90. So we can say that phi is equal to 90 degrees minus R. So this will be equal to, I solve it for you, this is degrees, but we know that just we find that phi is equal to 90 degrees minus r. Okay, so this will be equal to 90 degrees minus r is 26. So when we solve it, it comes out to be 64 degrees. So phi is 64 degrees. So using Snell law, we can find the angle of refraction, and then we, using this relation from the figure, we can find the phi. That's it. So next is the angle of incidence I at the bottom of the surface is equal to phi. The critical angle for the material of block is 30 in the air is 39 degree. Explain what happens to light after it meets the bottom surface. Okay, look here. Okay, this angle I is equal to phi. It is quite obvious that this is the alternate angle, so this angle should be equal to phi, and it comes out to be 64 degrees. Okay, I started this angle is equal to, because of this angle is 64 as phi is 64, and critical angle is 39 degree, it is given. So we solve it. When the angle of incidence is greater than the angle of, when angle of incidence is greater than critical angle, then the ray of light, then we have the phenomenon of total internal reflection. So ray of light will not reflect, it will reflect back to the normal, because when we know that this is denser medium, so it will when it emerges out, it will reflect away, bend away from the normal. So at critical angle it will go like this, and if the angle of incidence is greater than critical angle, then the ray of light will be reflected back in the original surface. So this is known as total internal reflection, and since this I is 64, this is 64, and critical angle is 90 degree, 39 degree, so 64 is greater than critical angle. So in the phenomenon of total internal reflection will occur, and the incident wave will not emerge out of the block, but it will reflect back into the block surface. So we can write it like that. Since the angle of incidence is greater than critical angle for the MMA material of block in air, that is 39 degrees. Okay, 39 degrees, and angle of incidence is 64 degrees. So light ray undergoes total internal reflection and it is reflection, and it is reflected back into the block instead of emerging out. So if you can write this much, you will get earn total marks of 9. So this completes question number 3. This was about the total internal refraction and the refraction laws. We solved it. I hope that you understand what I want to what I wanted to convey to you. If you like this video, please hit like. If you are new to my channel, please subscribe it and press the bell icon so that you can get all the notification of my coming videos. See you in next video very soon. Until then, take care. Allah Hafiz.